Mandy here with the Huntsville-Madison County Public Library, and I'm bringing you another STEM video. Now this one is going to be about myths and how we can prove or disprove them with science. Disprove means you prove that it's wrong, basically. So the first myth we're going to tackle is one from my childhood, which is longer ago than I care to mention, and it was about a little boy, actually the actor in the Life cereal commercial. The little boy, he ate an entire packet of Pop Rocks candy and then drank an entire soda, and he died. They say that he ate the Pop Rocks, he drank the soda, and his stomach expanded to the point where it just exploded. Now, as a kid, that's pretty terrifying because this was a super fun candy when I was a kid. Everybody wanted to eat Pop Rocks. I was so afraid that if I ate Pop Rocks and drank a soda that like something bad would happen to me. So I only drink water or like tea when I had Pop Rocks. Now, that's the thing with myths. They sound kind of true, but then they have a little bit of an unbelievable element to it. So let's see if we can prove or disprove this Pop Rocks and soda myth, okay? Now, you're gonna need a 20-ounce bottle of soda, a packet of Pop Rocks. I'm gonna do 2 bottles of soda, so have 2 packets of Pop Rocks if you do 2 sodas. So for each bottle of soda, you want 1 packet of candy, 1 balloon, and a funnel, okay? This is a big funnel. You can use small ones. Small ones are actually better, but this is all I have. So, all right, now pre-stretch your balloon a little bit. Pop Rocks are fun if you've never had the pleasure of indulging in Pop Rocks. They are teeny tiny little crystal looking candies that when you put them in your mouth, they start, it sounds like bacon frying, like there's this sizzling going on in your mouth. And if you get a big one in there, you can feel it pop. It's sort of like Rice Krispie treats when you pour milk on them, kind of that deal, all right? What makes them pop? What makes them sizzle? Why would Pop Rocks and soda make your stomach expand? Let's find out. All right, so you're gonna take your balloon. I'm gonna put it over the funnel because guess what? We need our Pop Rocks inside the balloon. Pop Rocks, the whole thing in the funnel. And push it down in your funnel in case yours has a lip on it like mine does and it doesn't want to go in there. Alright, pushing it in the funnel. Should have brought my tiny funnel from work. It's a little bitty cheapo plastic one, but they shoot straight down that one. Alright, so you might have to knock them down in there. Move your balloon around a little. Pop Rocks are wanting to stick to the side over there. We go. All right, and then once you get them in there, kind of roll your balloon off your funnel. Done with that. All right, now this is the tricky part. I pre-did the other one. All right, so we've got 2 balloons filled with Pop Rocks candies. Now the trick here, you have to open this and get the mouth of your balloon over the mouth, the open mouth of the soda without spilling the Pop Rocks in it because we want to do them at the same time, okay? So you got to be kind of quick after you open your soda, but don't like panic, don't rush. All right, you ready? Here we go. Ooh, that made a cool noise. I wonder what makes that noise. We'll find out in a second. All right, so you want to get it over. All right, got that one? So what makes that noise when you open a soda? I know some of you guys know. All right. Might need some help from the parental units on that because sometimes those balloons don't want to stretch well. Okay, so we got 2 sodas, Pop Rocks in the balloons, dangling like an earlobe. All right, you ready? I'm gonna try and dump them at the same time. You want all the Pop Rocks to go down into the soda, so you might have to jiggle your balloon a little. So here we go. 1, 2, 3. Shake 'em. This one's not wanting to come out. Well, so much for doing them at the same time. I had some big ones in there. Ah, they don't want to come out of the balloon. There we go. Now they're going. Oh, wait, what's happening? Oh, all these didn't go down either. Sticky balloons, man. What is happening? Can you hear it? I don't know if you can hear the sizzling and the popping. Now what's happening to our balloons? You see all these bubbles? Now, what is it about a soda? I'm gonna hold these just in case. I don't want them exploding in my kitchen. So, if you accidentally knock over a soda and it rolls around and then you try to open it, this fizzy stuff is gonna shoot everywhere. Now, what is the fizzy stuff? If you pour it in a glass, a clear glass, you can see these teeny tiny little bubbles. Now, the teeny tiny bubbles are what make the fizzy stuff, okay? Now, the way soda is made is they have this syrupy, sugary mixture. They put it in the bottle, and then they shoot high pressurized carbon dioxide or CO2 gas into the soda. That's what all those tiny little bubbles are. Now, carbon dioxide is what we breathe out, okay? It's what our body produces, and we breathe it out. We breathe oxygen in, carbon dioxide out. So when a soda fizzes, all that carbon dioxide gas is being released from those tiny little bubbles. Now, I still have Pop Rocks in my balloon. So, well, actually, one is bigger than the other one. Ooh, the air's coming out of that one. I have to hold it. So this sort of proves my theory that diet sodas are more carbonated than normal sodas. They feel that way to me. Like when I drink them, diet sodas feel super fizzy in my throat, which I don't like. And since this balloon looks bigger than this balloon, that could be why. Or there could have been more Pop Rocks in that packet. I don't know. You know, we're not super scientifically accurate on this one because we didn't count them or measure them. But, so that's how sodas fizz. What's up with the candy? It's made in kind of a similar way. Pop Rocks candies, they take their super sugary mixture and they force high pressurized carbon dioxide into the sugary mixture of the candy. I mean, I'm talking like really pressurized. 600 pounds per square inch is how pressurized that carbon dioxide gas is. They shoot it into the candy mixture, wait until it cools, and then it just shatters into a whole bunch of teeny tiny pieces because of the pressure, okay? Now, when you put Pop Rocks or any kind of candy in your mouth, the heat of your mouth, the saliva or the spit that's in your mouth starts to dissolve the candy. As Pop Rocks dissolve, this high pressurized carbon dioxide starts to be released. If you could look at a Pop Rocks candy underneath a microscope, you would see teeny tiny bubbles frozen in the candy. So when it melts in your mouth, all those bubbles start popping in that candy as it melts. And that's what you hear. It sounds like bacon sizzling if you get a really big mouthful of them. So I'm starting to think the Diet Coke is more carbonated here because we're still inflated and our poor Coke balloon is, you know, he's seen better days. So the inflation is happening here because that's showing you how much carbon dioxide is produced by both the candy and the soda. So if you ate a whole packet of Pop Rocks and then drank a whole 20-ounce soda, would your stomach explode? I don't think so. I mean, your stomach, you know, it's a pretty big organ. Now this probably wouldn't blow it up. Would it give you a tummy ache? Probably. Would you get a serious case of the burps? Definitely. But it's not going to blow up your stomach. So I think we busted that myth. Might give you a tummy ache, but you're not going to die from eating Pop Rocks and drinking a soda. May not recommend it because of the tummy ache, but you're not going to die because of it. All right, so I'm just going to move this a little over to the side because I have another myth that we're going to bust. And I have soda on my island. All right, so that myth was busted. Our next myth, I'm going to go back in time a little bit. Who likes pirates? I like pirates. I think they're really cool. Now, pirates may have been good at more than just finding and stealing treasure. Pirate eye patches. Most people think it's because they had an injury to their eye. Maybe they got in a really bad fight and like damaged their eye. So it's there just to cover up a gross looking eye. Maybe. But historians and scientists are starting to think it was for something a little different. Some historians believe that pirates may have been good at tactical technology as well. Very low tech, the eye patch, but it could do some pretty cool stuff, okay? Now, there are no actual records proving this because let's face it, most pirates couldn't read more than a map probably, so they definitely couldn't write. Pirates weren't making diaries or leaving historical records because they probably didn't care. I mean, they would read a treasure map. You know, they might be able to copy down the name of a boat or something, but they weren't extremely literate people. So, no actual records, but scientists believe that the eye patch they wore didn't really have anything to do with an injured eye. That it was actually, that eye patch was a weapon they used for maneuvering and fighting in the dark. What? How does that work? I'll tell you. Well, think about it. Have you ever been in a really bright room, like after dark, you know, like maybe you're on your way to bed and you're in the bathroom and it's really bright and then your brother and sister, you know, either one of them comes in and like, and turns the light out on you and shuts the door? Super dark, right? Or if you're in a bright hallway and you walk into your bedroom that doesn't have a light on, it's super dark in there. Well, the reason you can't see very well when that happens is because the eye is an amazing thing. But it has a little bit of a delay when it comes to night vision. It actually takes your eyes anywhere from 10 to 30 minutes to acclimate to the dark or to be able to see in the dark, okay? But what helps you see in the dark, okay? If you look in a mirror, this is a cool thing to do. If it's kind of dark, like you need enough light to see, but like get really close to the mirror and then like turn flashlight on, you can see your pupil, which is the black spot of your eye. If you're in a darkened room, it's gonna be really big. And if you turn a flashlight on, it gets really small. So when you go into a dark room, your pupil dilates or gets bigger to let in more light to help you see, okay? That's not all though. I mean, if our pupil getting really big is all we needed to see in the dark, I mean, we would be cats. When your pupil gets really big like that, it allows the rods, which are the part of your eye that helps you see black and white. You have rods and cones. Rods help you see in the dark. They help you see black and white. Cones help you see things in color. Helps me to remember that cone and color both start with a C. That way you know. So our rods that help us see in black and white actually produce a chemical called rhodopsin. Rhodopsin actually when your body or when your eye produces the rhodopsin, it starts to break down into other chemicals that tell the optic nerve, hey, it's dark in here, and it starts looking for more light. It makes your eye more light sensitive. Now, from the time your eye produces this rhodopsin until it breaks down and lets your optic nerve know it needs to see more, takes anywhere from 10 to 30 minutes. That's why it's not immediate. Okay, now if you're a pirate trying to take over a ship, the fighting will probably start outside on the deck of the ship. Bright sunshine. Oh, it's reflecting off the water. Wow, it's so bright. And then either your intended prey or maybe even your treasure darts off below deck. Well, you're going to follow, right? Well, what happens when you go from that bright, shiny, bright sunlight deck down into a ship? It's not like a cruise ship. Those pirate ships were dark. I mean, you go below deck, there's hardly any windows. They have like little candles and lights to give you just a little bit of light. It was really dark down there. So if you go from the sunshine through that doorway into a dark ship, are you just gonna stand there for 10 to 30 minutes to let your eyes adjust to the light? No, ain't nobody got time for that. You don't know who's in there. You don't know where your treasure went. You have to be able to see. Enter the eye patch. I made this eye patch, so I'm going to show you. I'm going to tell you how to do it. So you got your eye patch, all right? Now you've been out in the sunshine fighting, right? So this eye has gotten used to the daylight. You go down below, and all it took for pirates is a swap of the eye. This eye, which has been covered up the whole time they've been outside, is just full of that chemical rhodopsin, just waiting for a dark room. So all they had to do was swap sides. This eye, ready to go. Already got the night vision. They move it, they can already see in the dark. So if all it takes is just a switch, that's pretty amazing. I mean, how in the world would a pirate figure that out? I don't know. But that is why they wore the eye patch. Now, if you want to do this experiment at home, all this is black construction paper. You want to block out as much light as you can. So go for like black or dark blue. You can use a bandana. Again, make sure it's black or dark blue because you want to block out as much light as you can from that eye. And then just sit and watch TV for like 30 minutes with your eye covered up. Make sure it's dark outside. So while you're watching TV, you got your eye covered up. After about 30 minutes, go to the bathroom. Don't turn the light on, close the door, and swap that eye patch over. You'll see it's much easier to see in the dark than if you would have just walked in there and shut the door. So, pirates, who knew? They're pretty smart. All right, guys, that's all I got for you today. So, I hope you join us next time for some more STEM fun. Bye, see you later.